All right, so now what we're going to do for the next hour or so is go over programming assignment number one. Programming language per DM's class, obviously Java programming. You're going to write a temperature class. And we're going to do this together in class. And what you write in class, you can submit. This one is going to be due on the 26th of July. Not next weekend, but the following weekend. So if you're paying attention and you actually do this in class, not only will you learn the material, but you'll actually have the assignment done. So you won't have any homework. So this is kind of like the way the class works. You don't show up. You got to do it on your own or watch the video. Anyway, but you guys are all here because this is the first weekend. Actually, some people are missing. Anyway, we're writing a temperature class that holds two values, a temperature value, which is going to be a float number, and a character for the scale, which is going to be either C for Celsius or F for Fahrenheit. And then we're going to make sure that these two fields can only be accessed through what's called accessor methods outside of the class. So let's take a look then at what this is. I'm going to stop because I haven't talked about constructors yet. I'm going to hit that in a few minutes. But I just wanted to tackle this first paragraph because we know how to do the first paragraph already. Believe it or not, we know how to do the first paragraph. So let's see if we really remember how to do the first paragraph. I'm going to go over, and right now I have Hello World open. I'm going to shut this Hello World. I'm going to show you input and output. Today, I cut and pasted it during the break, and I stuck it in Hello World. But I'm going to leave this one out here. If you want to close the project, it's not a bad idea. I'm going to close the project. If I close it, basically it's still there. I just have to open it, but I won't be missing, putting files where they don't belong or mixing and matching files. So, File, New, if you're following along, Java project. And I'm going to call this Java project assignment number one. So I'm going to go ASSIN, assignment one. No spaces in the name. Or I can abbreviate it. I can do like that. Assignment one. We're good? I'm good. If we're good with that, I'm good with that. And I'm going to press finish. Now I have assignment number one. You're on your road to completing assignment number one. Okay. Assignment number one says to create a class. I'm sorry? Oh, okay. Hey, feel free to help each other, by the way. Yeah, it's easier than me helping her while I'm trying to do something else. I'm a little busy right now. Just kidding. We're going to write a temperature class. Because I can't spell temperature, I'm going to copy and paste this into the window. Which means we're going to actually click on the file menu again. Well, I'm going to open up the source code, and I know there's nothing in there. So it doesn't really matter where I do it, but I'm going to go into File, New, Class. And because it says create a new class. It's purposely worded like that to give you clarity in terms of what it is you're doing. Class. Okay, so we're going to create a new class. And I'm going to paste this one in here. Here's the other thing too. If you want to abbreviate it, you could do like this, temp, if you want. That works too. I think temp is a little easier for me to spell, so I'm going to leave it like that. Now, I'm going to leave this one alone, actually. And I'm just gonna leave it like this. I'm not going to make this the main. I'm just going to add the class. So I'm going to press finish. I'm going to add another class that I'm going to call my driver program, that I'm going to actually call my program or something. So I'm going to come back up. We're going to do this twice. I'm going to come back up to File, New, and I'm going to add another class. File, New class. We're going back to that screen again. This one I'm going to call main with a capital M because it's an object. Or you could call it my program. It's the one that's gonna have main in it. So now I'm gonna select this one. It says public static void main. Don't worry about it if you clicked it in the other one. It's not a big deal because you can always pull it out. So the most important thing is you've clicked here because you don't want to write it. It cuts down on the amount of writing you have to do. So now I've got main. I got public. It's public. So I'm gonna press finish. Now I have a main program, public class main. We've created a class. Public, private, protected. Public means it's open to everybody. Private means only inside of the class. Can, well, yeah, private you can't share. It's not open to anybody. It's private. Protected means in inheritance it's public, but otherwise it's private. And where is that? That's going to be in main. So I'm going to make my temperature over here, and then I'm going to make an instance of my temperature in main. We're going to see how instances of objects work. So what we're doing is creating a design for a program right now. You're always going to have one main, and you're going to have many objects that you're going to stick into it. This is our first object. This is our temp object that we're going to put in there. So I'm going to start with the temp object. So I'm going to close main for a second. Your temp object looks like this. And for those guys talking in the back, it's hard for me to yell over. And I don't have a microphone today, which means the people in the middle can't hear anything. So, oh, thank you. Now it's quiet. All right. So public class temp. This is where we're going to start. We're going to make some variables in this class. What are we going to do? In the first paragraph, we're still in the first paragraph, by the way. It says you have two fields. Fields are variables, and the two fields are for temperature. Are going to be a temperature value, which is going to be a floating point number, and a character for the scale. So I'm going to type this in here. I'm going to say floats value. And then I'm going to type in underneath the character scale. Very good. Now we're going to talk about methods. Now, we actually, believe it or not, did the first two sentences here. We created a class. It was called temperature. I called my temp. We have two. We have a floating point and a character for the scale, either C or S. These are examples of what it's going to hold, C or an F. Now we're going to make sure that these two fields can only be accessed through the accessor methods outside of the class. So that means we need to do this to it. We need to say private. We put the keyword private on there to say that it's only accessible inside of this particular method, of this particular class. It's not accessible anywhere else. Yes? Float is like it's like a double. It holds decimal precision. Like it could be, for a value, it might be 92.5 or 85.1 degrees in here. Precision. Doubles are a higher level of precision built into the data type to support money. Originally, people went, we got to have like calculations and rounding and all of those things, like with dollars. So if you're writing an accounting program, you're going to use the double variable type because it's a little bit bigger as a data type, holds up more memory, but it has more features in it to keep the precision correct. On a float, it's really an estimate. Not as precise. It's the same thing. So the language supports both floats and doubles, but if you want to be memory conservative and you don't really care about the precision of rounding and stuff, then go with the float. It's a lighter weight double. And there's methods on there you can do with doubles that you can't do with floats. That's about the only difference. So, a good question though, and then I encourage you to ask questions because that's how we're going to get most of the material covered. All right, I'm going to show you a trick now. After I show you the trick and we do the trick, then I'm going to explain what the trick is doing. We have these things called accessors and modifiers. In order to use the value in the scale, because they're private, we have to write public methods. And now this is the first time I've said this word method. A method is a function that returns a value. The value that we're going to return is going to be either a value or a scale. They call them setters and getters because one can set a value, the other one can get a value. Set and get. I'm going to show you a nifty little tool that I'm going to tell you what it's doing. So I don't have to write the code. You don't have to write the code either. If I go up to the project and if I go into source, and I go down to the bottom here. Oops, what's wrong with the source? Yeah, I don't know why it wasn't. It was all grayed out a few minutes ago. Now it's red, and now it's black. Source drop-down menu. Generate setters and getters is what we want to do. You're gonna see the light bulb's gonna click on when we do this, and you're gonna see what this does. And you're gonna go, oh, hopefully. Everybody find this option. I'm gonna wait for a few minutes here just to make sure everyone's on the same page. Generate setters and getters, or getters and setters. And then you're gonna pick. If you don't see this up here, it means you didn't declare it right here. You should see scale and you should see value, and you want to select them both. And I'm going to leave this screen up here for a few minutes. Actually, hold on one second. Let me pause this video. Let me pause this video real quick here. Oops, hold on one second. Here it is. All right, here we are. We're still at this screen here, and it says generate setters and getters. If you do not see scale and you do not see value up here, it means you did not declare them in here. So if you are going to use this nifty little tool, make sure you put that in the code first. It doesn't matter if you put private there. You can actually just put the variables there. I'm going to select them both, and I'm going to leave this one on public. I can start it again. Oh, the whole thing? Start what again? This little box? Yes. You put this in here? You have a temp? No? Hold on one second. Hold on one second. Pause. Okay, there we go. Okay, so let me try this one more time for those people who just strolled in after lunch here. Wherever the cursor is where the setters and getters are going to go. If your cursor's up here, they're going to go up here. You don't want them up here. You want them down here after scale. So if you have the window open and you don't know what it says in there, close the window for a second. Don't press OK yet. Just close the window. Go back to source, and if you do generate getters and setters, you'll see it says after scale. This is scale, and it's going to put them. Insertion point is after scale, which is right here where my cursor was when I opened up the window. And then sort them. You can sort them in pairs. You can sort them first with the getters and then with the setters. I'm going to leave them in pairs because I want to explain what these are doing. Leave it on public. I'm not going to generate any method comments or anything. If I don't select scale and value, I don't get an OK. So I'm going to select scale and value, and then my OK turns blue. This time, press OK. And all of a sudden, a bunch of source code ends up in your program. You should have now about 15 minutes worth of typing that you didn't have to type. And let me explain what this typing does, because you can do this by hand. You don't have to use the menu for this. But because this is our first day, I'm trying to automate stuff for you. I'm showing you the cheat sheets. These are called setters and getters. So we have one that says get value. That's this value here. And then we have another one that says set value. It's this value here. We have one that says get scale and set scale. That's a setter and a getter. What is it really doing? The get returns a value. The value returning is called value. That's the variable float value. The set scale sets the scale to scale, sets the set value, sets the value. And then we have this interesting syntax you're looking at, this thing. This is this object. It is this current object's, it's almost like mine. Yeah, it's the current object's variables. The current object that we just created called temp has two values. It has a value of the temperature we're going to hold, and it has a scale, Fahrenheit or Celsius. And the trick to this whole thing is that we're using these public methods to access the private data, and the data belongs to this object. So we can create a bunch of temperatures, and each one of the temperatures could have its own value, and which is what we're going to do eventually here. It's going to have its own value, and it's going to have its own scale. And depending upon the value and the scale, we can do different things to it to convert it from Fahrenheit to Celsius, stuff like that. So what we did is here taken in, and this is what they call a function. In its simplest form, this is a parameter to a function. This function takes on one parameter, it's a float value. Unfortunately, it's called value. And our variable is called value. If we don't want to use this, we could have done this. This is really bad, this to do this. If I called that one V, I could say this. And took out the this. So some people who are familiar with programming already may have already gotten this step and said, well, value is equal to V. What's value? Value is the value being held by this temperature. And it's equal to V. V is the value we're getting from the user when we set the value. When we run a method on an object that we're going to create, we're going to see how this works. But in the meantime, know that this is basically trying to differentiate between the two values, because we can't say this. We can't say value equals value. It'd be like this message here says the assignment to variable value has no effect. And which value are we talking about? The value we took in from the user or the value that we're holding ourselves? This is, well, I call this ambiguous. I don't know what value this is. So if I go this in front of it, it makes it so that it's this value. And you can see when I typed in this, I only know I have a scale and a value. I only have those two pieces of variable. So hold that in the back of your head. And what you're going to end up having to do is kind of absorb a little bit. You can't learn programming by listening to me talk. So by doing and by absorbing and by practicing, you're going to get, the light bulb will click on at different times for everybody. But the return, in this particular case, our methods have different data types. This one's a float to get value. So that the way, and if you get one of those textbooks on Java or any language, you'll see this is the general format. If you leave out the public part of it, it's assumed that it's public. It's good practice, however, and all the tools are going to put the public in for you, but it's really optional. You don't want to make a method private, because if you make a method private, you can't run it. It doesn't work. And the idea is we're going to use the public methods to manipulate the private data. And so we're protecting the data in this protective mechanism by only allowing these public methods to set it and get it. So we can't mess around with this. And we'll play around with this as soon as we get an object going, and I'll demonstrate the difference between the public and the private to you. But right now, just kind of take it as face value that that's what's going on with this. So in here, we have an opening and a closing bracket that contains the code for the method that we're programming with a function. We have a data type. We have a get value. This one doesn't take on any parameters. It just returns it. So when we get the value, we're returning the value that's being held by this object. And then when we want to set it, we have to give it a value to set. We'll see those calls and returns in a few minutes. But right now what we've got are a couple of really cool constructors going on. Setters and getters going on. So our temp class is done for the first paragraph. Because the second sentence, this last sentence we just did, says make sure that these two fields can only be accessed through the accessor methods outside of the class. And that's what we just did, because we made the data private. Oops, where'd it go? Here it is. We made the data private so that we can only get it through the public methods. Let's go to main. What I want to do right now, and what everyone should do, is save and close temp, so we don't have any confusion of what we're doing here. And double click on main. I'm going to get rid of this little stub. It says to do stub. I just get rid of it because I don't like to look at it. We're going to make another version of a main program that's going to make an instance of this temperature, and this is how we use it together. So if I type in temp as my data type, because temp is just like string is an object, temp is also a new object that belongs to my project here. And the way that I create a temp, I give it a name. You know, it's kind of like saying this. It's sort of like saying string name, and then I have a data type along with a variable name. Well, I can do this. I can go temp, my temp, 1, if I want to. And then I've made an instance of my temp. If I want to allocate memory for it and actually use the instance, I would go temp, my temp is equal to new temp. So whereby I've created a new temp. I'm going to get rid of the string because you don't need it. And it's going to tell me that I've created this local variable, but I've never used it. And I'm like, okay, but you didn't give me enough time. I just started writing this program. So let's see if we can all write that line of code. Temp, my temp 1 is equal to new temp. And then if we want to make another temp, I'm going to make another temp here. I'm going to go temp, my temp 2 is going to be equal to a new temp. Now I got 2 temps. You should not have any error messages. The yellow stuff's okay. It means you've created an instance, but you haven't used it yet. Ooh, there goes the door. Ah, sorry for those people in the back. It's kind of dark in here. You guys want more lights? No? Okay, good. Anyway, because you can see the screen better. Yeah, I can really see the screen now. You guys want the door open or shut? Shut. Excellent. Thank you. All right, so let's see what happens if we system out this temp. We're going to get a memory address is what we're going to get, because what we have is an object here. So if I do system out, this is just a test to make sure we have everything working. System out, system.out.println. I'm just going to put my temp 1 in here. Oops, install extension. I don't know where that came from. Wizard. How come I have a wizard in here? What am I doing here? I accidentally pressed on something. What is this? Did you guys get this too? What is this? It's what? Cancel. I think I accidentally clicked on something. I'm not sure what I clicked on, but anyway, let's just leave that one alone. So if I print this out now, I'm going to go up to run. I get temp at 6773227B6. That's because that's the object. And the object is a reference to a memory address. It's a temp, and the temp is sitting at memory address 67. I don't really care about the memory address. The memory address isn't going to really do anything for me. Java does not have pointers. You'll be happy to know we will not be talking about pointers in this class. However, everything's a pointer. So we just actually printed out a pointer address of temp that's sitting at this memory address. Doesn't really do anything for us. Instead, I'm going to go back, open up temp again. I'm going to show you how these variables work. I'm going to take out, this is bad because this is not what the first assignment wanted us to do. But I'm going to experiment here. We're playing around, we're learning what these data members and member functions are doing, the fields and stuff. Make the float value and the character scale public. So take out the private. Let's just make this public right now. So each one of the temps has a value and a scale. Leave everything else alone. We just took out the protection mechanism here, so we no longer have private. They're both public, which is not a really good design, but we're just going to play around with this for a second. Save temp. You can close temp now. Let's go back to main. Now main, if we use what's called a dot notation, and the dot notation looks like this: my temp 1 dot. Let's take scale, and scale is a character, and have that one equal to, and I'm going to explain this in a second, Celsius. And then my temp Whoops, case sensitive, temp1. Oh, did I leave? Oh, temp. Oh, well. Temp dot value is going to be equal to, what is a Celsius? Maybe I should put Fahrenheit in here. No, but, so how, like 80 degrees? Yeah, 80.5 degrees. Just giving it a float value. Oh, it doesn't like 80. What's wrong? Cannot convert a double to a float. Let's just go 80. That can get converted. I'm not going to go into that. Just give it to 80 degrees. That's pretty warm. Or you can do 75. It's Fahrenheit. If you like Celsius, make it Celsius. Doesn't matter. We don't have any methods right now to work with that anyway. So now this is going to set temp1. Oh, actually, let's do it for both. I'm going to set temp1's value to 80. Now I'm going to do temp2. So do it for both. My temp2.scale is going to be equal to Celsius. Make them different so you can see the difference between them. And then my temp2.value, temperature 2 is going to be, what's a Celsius value for 80? I don't know, like 20? I don't know. Let's just make it 20. I just want to see two different values in there. They don't have to be real values. So I have, these are called instances of objects. These are instances of objects. And I have two of them. I have a temp1 and a temp2. And I've set the temp1 scale and the value to two different things. So I can print out as an example temp1. And if I'm going to do that, I'm going to use the dot here value. So I'm getting at the value of the variables by using a dot notation. And this is going to print out the value of temp1, which is 80. So if I wanted to do what we learned this morning, I can put a little thing in here that says my temp1 value is going to be equal to, and then use that plus sign there. And then we have my temp1 value. And then I'm going to copy and paste this one and do it for temp2 so you can see both of them being printed out. Let's see, paste. And I'm going to just change the 1 to a 2. Everybody following me so far? Or do I need to pause for a few minutes? Or I know I'm faster probably typing. Anyone need more time? Raise your hand. Okay, good. I'm going to pause this for a second then. Okay, now if you run it, you're going to get the two values. So I'm going to run mine because I don't know if I've done that yet actually. And I have one temp value at 80 and one at 20. So mine's working. Hopefully yours is working. If you've gotten this far, what you've done right now is you've set a variable for an object, and you've printed out the variable using the variable values. Is yours not working? A good question was asked, and I'm going to answer it while I'm recording and talking to everybody else now. Somebody asked, why separate it out? Why put temp in a separate object? It's a way of modularizing your objects for reuse. If I put it all into one file, I actually have to go back to assignment number 1 every time I want to do my temperature. If I want to keep temperature and put it in a repository and kind of use it again and again over and over again, I only have to make the class once. And then I can use it in any project that I want over and over again. And I don't have to reinvent the wheel every time. So for object orientation, it's called reuse. And when we make objects and we stick them in like common directories and common folders, and we put them in packages, which I'm probably not going to talk about today. I'll probably hit packages next time. But in essence, we have a bundled set of these things, or objects and packages. We include the package, or import the package, and then we have all this functionality pre-built for us. So in the real world, a development team will split out. Some people will create this object, some people will create that object over there. They all create their individual objects, and then they bring it all together in the same program. And then they reuse what everybody else has been doing. And then the more the company's programming, and the more objects are created, the bigger the repository. It's basically a resource kit. essentially. I mean, you got a lot of objects eventually to work with. Okay, and just to answer that question. So what we've done right now, if we set variables and we have printed some of the values out. We didn't do anything with scale, but you could play around with that if you wanted to. No biggie though. But we use these as a as a public variable. If we go back to temp, we're going, now if your program is working great, you're going to have some errors in a few minutes, because here's what we're going to do. We're going to go back to temp, and we're going to change the public, and we're going to put it back on private. And then save temp. We're introducing an error because we have to do something different with this. But save temp when we're all done. And all of a sudden, this red stuff comes over here. And you're like, why did you just make us do an error? Because we really want to protect this data. We don't want to, in the main program, to do this. This is not good. So instead, we're going to use what's called setters and getters to set this private data. And the setters and the getters are the public interface. And then generally, one person in the class will probably ask me the question. They'll say, why? Isn't it easier just to use the variables like this and make them public? Yes, that is easier, but there's no protection with this. If you use public methods, you can control when they're set and how they're set. We're not really controlling this right now. We're just returning values and getting values. But you could put a check in there, like don't let the temperature be anything but F or C. You know, like, and we can do that in a few minutes on the scale. Or don't let, you know, if someone says, my temperature scale is Z. We're going to, no, I'm sorry, you can't, we don't take a Z. It has to be a C or an F. So you can kind of sort of put some quality control on the values that are being set in the range of values and stuff. We're not putting that code in here right now. We're just kind of going low key on this one. But we have functions now to set values. So we're going to rewrite these over here. Instead of putting a dot value to do it this way, we're going to still use the dot, and I'm going to write how this looks. It says set scale. And then we're going to put this in the function, in the method call brackets like this. So now the function looks like this. So we have a set scale F, and then we're going to have a set value. And in our naming conventions, because we've called them setters and getters, oops, this is a set value. Set value. There we go. We are using this small character in the beginning and then a big character, capital character, to separate. And all you have to do is take a look at your temp file if you want to know the names. And this is the set value, and this is the set scale. And you're running, this is how we're running the method, by the way. We run the method like this, and we send it a parameter. In this case, we're sending it 80. In this case, we're sending it F. These are the parameter values we're sticking in. So this is the syntax for running a method on an object by using the dot notation. So I'm going to finish mine. We need to do it for, we need to change all of them in order for it to work. And then down here, we can't return the value, but we're going to get the value. So I'm going to type in get value. And because we're getting it, we're not passing it any information. This here is empty. So we know that this is a method call because of these little opening and closing brackets next to them. This parameter stuff. If we're just going to get something, we're going to return the value. And if we set something, we're going to assign the value. So this is the same program we had before, but now instead of using public data, we're using private data, and then we're using public member functions to access the private data. So if you run it when you're all done, it should work, and it does. Therefore, I'm going to leave this up for a few minutes for those people who haven't finished typing, so that you can finish typing this one. What's wrong? Okay, so I'm going to walk around and help. Let me pause this. So these are method calls. You don't want to go equals. That's a common thing I've been seeing around the room. This method here is this method over here. Set scale. You run the method by using a dot notation, and you run it with a parameter that you're sending it, and the parameter has to be a character. Which is interesting. If you do this, you don't have to do this, but if you go like my temp1 and I go dot, I see I get a bunch of methods that says get scale, set class, get value, toString. There's a bunch of methods that are already built in, and then there's the ones that we created. That shows up on the dot menu. If you forget what it's called, you can actually pick it from the little menu. So at this point, we have the same program written twice, essentially. And I believe now we're ready to move on to the next part of this assignment, if we're in good shape right now. So let's go back to the assignment. Here it is somewhere. Here it is. So let's go to constructors. The class should have 4 constructors. Oh my God, what is a constructor? Well, I'll have to tell you about those in a few minutes. 1 for each instance field. Assume 0 degrees if no value is specified, and Celsius if no scale is specified. Okay. 1 with 2 parameters for the 2 instance variables, and a default constructor set to 0 degrees Celsius. Now let's talk about these things called constructors. When the object is created, the object has these methods called constructors, just like it sounds, construct. When the object is constructed, these methods fire automatically, and they fire when the instance is created. Up here, these are the instances that we created. We created 2 instances of these 2 objects. One is called temp1 and called my temp1, my temp2. We ran a default constructor, but we don't actually have a default constructor, which means don't do this. Don't do this. But if I comment out the value that I set, and I run the method, I run the main, I get 0 and 0, which is what some of you were getting when you were printing stuff out because you didn't actually set temp1 and temp2, you set temp2 twice or something, I don't know. Because nothing's being set by default. It's always just going to be 0. So what I can do, and let me show you how to do this using the automated tool, and then I'll explain what I did. The same thing we did with the setters and the getters, we can do with constructors. I want to put the constructors at the top of the code. So I went ahead and went all the way up to the top of temp, and we're in temp right now. You want to be, or temperature, depending upon what you called it. Put some spaces down because we want to add some code underneath value and scale. And we're going back up to that source folder. So go to the source menu option there. And in here we want to generate constructors using fields. So this is the option here that I have highlighted on here. Generate constructor using the fields. When we create the object, we're going to automatically assign the fields. The fields are the value and the scale, so that we don't have to go and set this, set that, set everything. Instead, we can run the constructor when we create the object, and it'll set us for us automatically. So if you select this option, same window as before on the setters and the getters list should look extremely familiar to you. Make sure you have value and scale selected. And then we have public, which is good. I'm not going to do the comments or anything. I'm just going to press on OK. Now we have these methods that are here. I'm going to take out the extra line so my screen looks a little cleaner. I have one now, and this was a constructor that I created. and my constructor says public temp, and the temp has a float value and a character scale. And it's the same as I'm doing here with the set values. I'm going this dot value is equal to value, but this one's taking two. I have a value, comma, a scale that's coming through. And notice that the same name as the class is being used as the constructor name. And super is an interesting one. Super runs the constructors of the super object. This object is called this. The super, or supervisor object, the one above us, is called super. So a call to super, you're going to see that I could take this out. It's not going to matter because super isn't really doing anything. I can remove super. I'm going to leave super in there because it looks better. It's more appropriate. And the auto system put it in there for me, so no harm done. I'll just leave it there. But super is really not going to do anything. If we wanted to, we could send super some parameters to set. And we're definitely not going to look at hierarchies and inheritance today. That's overkill for the first day. But we'll look at it next week probably. But all right, next 2 weeks. But super could actually initialize variables or fields of the superclass object. So superclass is above, subclass is below. Classes are in a hierarchy of super and sub. If you have time within the next 2 weeks and you want to download that Deedle and Deedle book and you can start reading through some of the terminology, it might help you go at a little slower pace to absorb a little bit more. Or you could do some Google searches on, but inheritance is way too far ahead for us right now. So let's not worry about inheritance. So what we have going on here is that we're going to use super. Just leave it alone right now. We'll get back to it later. But this dot value and this dot scale. So because we've created this constructor and a constructor takes on these two values, when we construct the object, we can pass those two values to it automatically. So I'm going to save this one and I want to show you how this constructor actually works. So the value and then the scale. Value comes first, scale comes second. And so I'm going to change these guys here and then I'm going to comment out these guys here. Because these guys now turned red on me. Because I don't have a default constructor, I created another constructor. We're going to go back and create a default constructor in a few minutes, but I want to show you what this new constructor does. So it's a value. So I'm going to go 100, comma, Fahrenheit. And this one here, I'm going to go 200 degrees, comma, Fahrenheit. It's a really hot day here. Oh, okay, the 200 is a little outrageous. Let's go 110. That's pretty hot, and 90. So now I created the same two objects. And if you don't comment out this code here, this code's going to overwrite this code. If I really want to create and use the constructors and create the objects by passing it the information when I create the objects, I'm going to use the constructor. That is this function here. That's this. So I'm going to go back here so you can see it. But if I save this, the little red stuff should go away. And it does. I'm going to pause the video, give you a few minutes to type this in. Okay, we're making progress. So these are not this is called a constructor. And we have made an instance of this object using this constructor. We can now go back to temp and put in what's called a default constructor. I'm going to type this one manually. Am I going to type it manually? Let me show you where you can do it actually. In the source code folder, if you put in the constructors from superclass, it'll do the superclass ones. We don't want to do that one. If we generate, so usually the default constructor comes up, but this one isn't coming up. This one's using fields. So I'm going to leave this one alone, actually, and just do it manually. If I do it manually, we're going to type it, which doesn't mean do it manually. Which is, probably should be typing all this stuff anyway. But we're going to create what's called a default constructor. A default constructor goes when no other constructor is called. So it starts out public, and this is how our other methods are running, temp, but we don't put anything in the opening and the closing bracket there, so it doesn't take on any parameters. And we still put the opening and the closing curly brackets in there, because the instructions want us to use a default constructor to set values if no values are specified. So I'm going to go to the Word file if I can find my assignment that was here. Here it is. And in here it says under constructors, the class should have 4 constructors. Well, we've only created 1 so far. We have to create the other ones. We're going to create 1 for each instance field. And I'm going to show you how to create 4 of them in a moment here, and then I'm going to let you create them, and we're going to take a 5-minute break at the same time. But if nothing is turned in, we're going to assume that the 0 degree if no value is specified, and Celsius if no scale is specified. So I'm going to stick this one in the default constructor. So I'm going to come over here and I'm going to do this. I'm going to say this dot scale is equal to Celsius. And then I'm going to say that this dot value is going to be equal to, oh, you have to put a semicolon at the end. I missed that one. Value is going to be equal to 0. Now, if I don't set a scale and I don't set a value, I'm going to get C and 0. So now if I wanted to, because I made this constructor, I can go back to main if I want to, and I'm going to make 2 more temps. Actually, I'm going to make 1 more temp. I'm going to call it temp my temp 3. And now this one's going to be equal to a new temp. And now you can see that there's no error message this time, because we just created that constructor. And the constructor that we created was the one that didn't take on any parameters at all. So here's what you're going to do, and then I'm going to pause the video while you're doing this, and I'm going to do it. Well, I'm going to do it while I'm talking, and then I'm going to have you do it, and I'm going to leave the code up here so you can cheat. You can look at it. We're going to combine this with you doing a lot of typing and me taking a break for a second. The rest of you taking a break for a second, because it's after lunch and we've been going for a while. So. This is the default, so I'm going to label this one as default constructor. And this one here is a constructor that sets value and scale, so I'm going to do that one. I'm going to do this. I'm going to say sets value and scale. And this is a constructor, so I'm going to label it this way. Constructor that sets value and scale. Now, if you want to cheat, you could do this. I'm going to copy it here. What we want to do is get all the combinations. We want 4 of them all together. We have 2 of them. So we're going to add 2 more. The 2 more that we're going to add, one's going to take the scale and one's going to take the value and set the corresponding scale and value to whatever the default's supposed to be. So we can set one or the other. We don't have to set both of them together. So here we have one that sets none of them. And here's the one we have both of them together. Now we want to set one or the other, is what we're doing. So I'm going to make a little room here. I'm going to push this up this way. And I am going to, took a cheat sheet. Instead, I cut and pasted it. Now you're going to get a little message because you can't have 2 that are the same. And we're not quite ready with this yet. I'm going to change this comment and I'm going to say sets constructor sets scale and default for value. And then in here I'm going to put, what is it, character? Character C for scale. What did I do down here? Let's see. Character scale. So I'm going to do it this way then, so it matches. And then for the scale, this is going to be equal to scale. And then value is going to be equal to 0. And then I'm going to cheat it. I'm actually going to do this. I'm going to copy it, paste it here. And then this is a constructor that sets the value and the default for scale. So this one's going to be value, and this is going to be, in my case, it's a float. And so the scale is going to be C, which is my default, and the value is going to be value. So now we have 4 constructors. We have the one that does absolutely nothing, except for that it sets the scale to C and the value to 0. We have 2, the one that sets the scale and one that sets the value. And I can move this over a little bit here, make it line up like with the rest of them. And then we have the one we started out with that does them both. So these are the 2 new ones. Actually, there's 3 new ones. I don't know how to get, maybe I can make this screen a little bit bigger. See if I can make this screen a little bit longer. I can almost make them fit. Actually got them fitting here. Except for now I got to figure out how to pause this video at the same time. Let's see. Oops. Oh, it still fits. That's good. So I'm gonna pause the video, and then I'm gonna allow you a little extra time here because this is gonna be time consuming because you have to type them. Make sure you've got the default. Put this one in it that sets the scale and uses the default value, and then set this one that sets the value and uses the default scale. And then the other constructor is the one we have already. So let me pause this one. Okay, the last part of this here is that we're going to finish this, but we're going to do it in 2 segments. I'm going to stop for a second. But what we're going to do is now in the main program, we're going to run all 4 constructors. So we created 4 constructors, and now what we're going to do is run them. So if you remember, we ran the one that took 2, and then we ran the one that didn't do anything. So this is, I'm going to label this one here, this is the default constructor. So I'm going to put some comments in here. Default constructor. This constructor over here runs both. Constructor runs both, or assigns both. Assigns both values. Now we have one constructor, and here's the other thing, and then I just noticed that a couple students weren't doing this. Or we're doing this. You have to name your instances different names. Yeah. So here's, if you name them by the same thing, you get in trouble. So you have to go like, for example, temp, my temp 4 equals new temp. We have 2 more combinations. We have one that sets the value, and then the other one that sets the scale. So this one's going to be a 90. Oh, let's make this a 120. So this is the constructor. Constructor sets value. And then we have a constructor that sets the scale. My temp 5. So I got 5 temps here. How did I get 5? Oh, because I have 2 of them up here that do the same thing. New temp. This one's going to set an F. So temp 1 and temp 2 are both using the 2-valued constructor. The default constructor is temp number 3. Temp 4 is using the temperature value, and temp number 5 is setting the scale to Fahrenheit. So put your 5 instances of objects. You can actually, no, you only have to do one of them up here if you wanted to. And I'm going to scroll up a little bit because I'm going to put 4 printout lines in here so I can see the values. So I'm going to copy and paste one of these print system outs. So I got 1, 2, actually I don't really need 2. I'm going to put 3 in here. 1, this part you could just play around with. You don't actually have to do all of these. 4 and 5. And then this is going to be 1, 3, 4, 5. Now we've been running the get value. We also have a get scale. So I could switch this around a little bit if I want. For example, this one here I can say get scale. And then this one is going to be get scale, maybe. What I want to do is just print some of this information to the screen so that I can see the constructors are working. And theoretically, if I'm only setting the value here, the constructor out here is setting the value and then setting the scale to C. And then on this one is setting the scale, it's setting the value to 0. So on the one that sets the scale, which is this one here, temp 5, I really want to get the value. This value is going to be 0 in the temp 5 because I'm not setting anything. So I'll leave this up for a few minutes because I know people are still typing, especially if you're in the back. So these are the constructors you want to put up, or the calls. So let me pause this again. Okay, so the constructors are all made, and I'm going to try and see if I have this done correctly. On my constructor section, it says the class should have 4 constructors. We just created them, 1 for each one of the instance fields. Assume 0 degrees if the value is specified, and Celsius if no scale is specified. So if no value, no scale, it's 0 and C. 1 with 2 parameters for them both, and a default constructor that sets the degrees to Celsius and sets the value to 0. So that is pretty much what we have here, actually. And I put in some printf statements. I just want to make sure my code works before we continue. So I'm going to run. And I'm noticing that my code works. Woohoo! So if you missed any of these steps, go download the video. I'm going to actually label it assignment 1, and I'm keeping it all together. And I'll put it all in the same video so you don't have to keep going from one to another. And I'll scroll through the code one more time so you can sort of see where I'm at now. Here is the temp file. Temp file looks like the temp class. It looks like this. We have private float value, private character scale, and we have a default constructor and a constructor that sets the scale and the default value, and one that sets the value with the default scale. We have the one that does them both, and we have a get get value and get scale, a set value and a set scale. So there's the completed so far temp file. Just in case you're looking at this video later and you're trying to copy the code, you can always hit pause or stop on the video and type it in on your computer. And then here's the main from the start to the end. Not too bad. Looks like I didn't use temp 2 for anything. I could probably pull that out, but I'll just leave it alone. Alright, so let's see what else we can do to this. We're going to make some methods now. This is the easy part, believe it or not. The class should have 3 types of methods. 2 methods to return the temperature. Oh my god, we got that already. Well, do we? 1 to return the degrees in Celsius, and the other to return the degrees in Fahrenheit. Now we're going to do temperature conversion is what we're going to do. Use the following formula to write your 2 methods. So we're going to return Celsius, and then we're going to return Fahrenheit. So we're going to pass a Celsius degree to return Fahrenheit, and we're going to pass a Fahrenheit degree to return Celsius. And we're going to run the corresponding method code to translate it. So I'm going to take this one first, and I'm going to copy it because I'm a really bad typist, and I really don't want to keep going back and forth with the formula. And you know what, for the life of me, I don't know. I didn't like chemistry or whatever that was. I don't even remember the formula, but physics, I don't know what that was. But anyway, we're going to go to the temp class. We in the temp class. We're going to write now a method, and I'm going to stick the method at the bottom of the code. We're going to write, and we're not going to use the menus this time because now we know how to write these methods. We wrote 4 of them already for constructors. So I'm going to start out the same kind of way that everything else is, but this one's going to be public And this one's going to return, oy vey, what are we returning? Good question, let's see. Degrees. So this is going to be the value we're returning. So this is going to be, I'm going to make my method name return a value. So I'm using a float value for my value. So public float get Celsius. Did I spell Celsius right? No, probably not. How about get C? I can spell that. And it's going to take a float value that I'm going to call V. And I just put, oops, what's wrong with this? Let's see. This method must return a value, float. Okay, so I'm going to put in the return. And right now, I'm going to put in 0 just to return something to get rid of the error message. So we're going to write, and I call these stubs. These are sort of like my method stubs. It's going to be that we're going to fill the body in a few minutes, but we're going to write this in pieces. So this one, next one's going to be public float. If I can spell, see, I'm a terrible spellist. Get F, and this is going to take a float V. And I'm going to put an opening and a closing bracket, and right now I'm just going to return 0. So see if you could type these two functions, function stubs, in on your code, function methods. We're going to run these just like we ran set scale and get scale. We're going to get the C, or we're going to get the F. And one is going to be get Celsius. We're going to send it to Fahrenheit, and we're going to go get Fahrenheit. Then we're going to send it to Celsius. I'm going to assume you guys need a few minutes to type this in. So, while you're typing it in, let's play around with the formula. So I'm gonna paste in, and I'm gonna change this so it looks like C code. This formula in here, and you'll be surprised how well this formula actually adapts to C code. So I'm gonna create I'm gonna call this one degrees C, and I'm gonna say float degrees C, and it's gonna be equal to 5 times, oops, 5, is it 5 times? I wonder if that works actually. Value minus 32, or it's V, minus 32 divided by 9. I'm going to have to use programming syntax for this. And make sure that this minus is a real minus. If I want to, I don't even have to do this. Actually, I could put this all in the return line. Let's do it. I'm going to put it on the return line, make our life easier. Return. There we go. I'm returning 5 times V, which is our Celsius value. Or, excuse me, our Fahrenheit value. Or did I do this backwards? Well, I'll have to do them both anyway, so let's see which one I actually did. Degrees in Celsius, so this is going to take an F. So I'm going to change this F to an F. That way I know what I'm doing here. F, there we go. So this method takes a Fahrenheit, takes an F, and turns it into a C. By returning 5, so it's going to be Fahrenheit minus 32 divided by 9. So I'm going to assume the formula works. And then this one's going to take a C, and turn it into an F. So I'm taking an F and I'm turning it into a C. And I'm taking a C and I'm turning it into an F. And if I wanted to, I could actually change this value to C. And I'm going to make it small c. Oops. I know you're like, quit playing with it. Okay, so let's go back to my cheat sheet formula here. If I want Fahrenheit, I'm sorry for those people who are copying. I'll put it back in a second. Here we go, we're back now. I'm going to return something, and this is how I'm going to return this one. This one's 9 times C divide by 5 plus 32. Did I do it wrong? No. If I want to make this look cleaner, I can actually put brackets around the whole thing, like this. And I'll leave this up for a few minutes for you guys to copy. All right, so we're going to continue. We have the two. Let's see what we got here. Just make sure we got everything here. Oh my God, there's more stuff. 3 methods. So let's see what else we have down here. I'm almost getting tired of this assignment by now. So we wrote the 2 methods. Now we want to do 3 methods to set the fields. 1 to set the value, 1 to get the value. Let's not do that. Do we want to do that? No, I don't think so. Do we want to compare 2 temperatures? No, I don't want to do that either. So what we're going to do, for those people who are paying attention, steps number 2 and number 3 are optional. We'll do them next time, but today I think we're hitting this like capacity limit on mental effort. I know I am. So if you so desire, well, we actually have to finish main in a few minutes. If you want to challenge yourself, write these 2 more methods. Otherwise, I'm going to do it in class next time. You can turn this one in as is as soon as we're done with it today. The number 2 and number 3 are optional. It's just more methods. What we do is we go in there and we're going to write 3 methods here and then 1 method that's going to compare it. But the one that's going to compare it is a little bit more difficult and is going to cover some topic areas that we haven't touched yet. So I'm going to continue this tutorial next time we meet on Sunday the 26th or 25th or something like that, July something, 2 weeks from now. So we're going to do this, but not today. If you want to turn the assignment in on the 25th or before, you can turn it in as of today. I'm not going to cover assignment number 2 instead because this group is going a little slower than I expected. I'm going to postpone that one. So assignment number 2 is not due in 2 weeks. We didn't get there yet. We'll do that one in class in 2 weeks. It is not due in 2 weeks. But when I'm all done with this assignment, I'm going to give you other stuff to do. I know you're like, man, just get done with this assignment. All right, so we're just gonna run these 2 methods. So we're in main, we're gonna add, and this is the last part of this assignment. We're gonna add. Let's do it at the bottom. I'm gonna add 2 calls to these 2 methods, and actually, I'm going to show you how to put a call inside of a call. So I'm gonna put it inside of the system out actually, because I want it to print to the screen. So I'm gonna go system.out.println, and I'm going to print out temp5 in front of me here. Temp5 is a good one. I'm just going to run one of the methods. They're the same if you run one or the other. So I'm going to take this Fahrenheit temperature and convert it to Celsius, but I don't think temp5 has one. No, I'm going to take temp2 because I haven't done anything with temp2. If you have a temp2 up here, we have 110 degrees Fahrenheit, and I want to convert that Fahrenheit to Celsius. So the name of the method that I created for the Celsius was getC, and we're going to send it an F. So out here, I'm going to say I'm in the wrong spot. Down here, I'm going to say my temp2 is blank in Fahrenheit, or in F, and now I'm going to run the method to convert it. I'm going to add this with my temp 5 dot get value. Right now I'm going to make this screen a little bit bigger so you can see what I'm doing here. As soon as I get done with typing this, I'll put it out. And actually I'm going to make this a little shorter. Temp 5 equals get value. I think I'll just put the F in here. F and plus concatenate that with my temp 5. Temp 5 dot get C. And the C value I'm going to send it is the value. So let's see, why is it scrolling off my screen? I think I need to move it this way a little bit. Get C, and the C value I'm going to send it is the temp 5 get value. And then I'm going to put a semicolon at the end of that line. And let's see if I have any error messages on that line. I do. Let's see what the error messages, oops, excuse me, are doing here. I've got an extra one of these in here. My temp 5 dot get value. There we go. So let me move this over so you guys could type this in. Ooh, it's a little hard to do. Actually, I could do it this way. Well, you guys have this part down, right? The system.out.println. I could do this. Put it in 2 lines. There we go. Now it fits. If you have the plus as concatenation, you can actually put it in 2 lines. You can, in fact, you can write the whole thing in 1 line if you wanted to. Actually, let's see if it works. I'm going to run it just to make sure it works first. Unresolved compilation problem. Let's see. I might not compile it. No. Line 8. Oh, I forgot to put a semicolon over here. Oh, you know what? I think I accidentally removed it. Let me just make sure my code works, actually. My code is working. Oh, it's -7? It's really cold. Let's see. As soon as I get done playing with this, I'll leave it up for a few minutes so you guys can copy it. Alright. Believe it or not, that's the end of the program. So I'm going to run it. If you run it, when I run it, I get that, oh, it's 0 degrees. It's -7 degrees Celsius. I guess I didn't put a temperature in for number 2. Did I? My temp 2 didn't have one? Temp 2 at 110? I don't know. Temp 5. Why am I putting temp 5 in here? That's probably why. I wanted to do temp 2. You know, that might explain it. Temp 5 doesn't have a temperature. Temp 5 has 0. So now if you did what I did, take your temp 5, change it to temp 2. And now we're troubleshooting our program. Now we have 110 that's equal to 3 degrees Celsius. That makes more sense. In fact, we could even do this if we wanted to. We could concatenate and add a C on the end of it. So I'm concatenating my end of my output. I'm putting a C on the end of it. So if I run it, now it looks like 110 degrees F is equal to 3 degrees Celsius. Is that wrong? Is that wrong? I think our formula is wrong. Maybe I'm going the opposite direction. Oh, you know what? Our percentage is wrong. You're right. It's divide. Yeah, you're right. You know what? We wrote the wrong. Nobody even caught me on this. Let's divide it instead of doing the modules. All right, now let's see if we get any better results. Is 110 degrees Fahrenheit equal to 43 something Celsius? Yeah. Is that about? I don't know Celsius. I know Fahrenheit. Actually, you know, I know 70 degrees. I'm going to change. Which one are we doing here? So if you didn't get the memo, we used the wrong formula. We need to put the minus in for the divide. We need to put the divide in. I took the divide out and I changed it to modulus. So don't worry about it if your formula is not right and you're not being graded on your formula. So don't worry about that. So I'm going to check number 2 here. I'm going to check and I'm going to make 270 degrees. I'll run it one more time just because I want to see something. Yep, that's right. Okay, I know 70 degrees. We could do some rounding here, better output, but we have a pretty good running program. So if you're happy with your program, clap your hands. No, I don't know. Let's not do that. So save your program. I will put this video out. If you missed any part of it, your program's not working, you can pause the video, look at the code, compare your code to the video, and see where you went wrong. How do you submit this sucker? Let me show you how you submit it. You want to close your project down after you save it. You're going to go into the workspace folder. Mine's in documents. Was in documents. Here it is, workspace. And this one's called assignment number 1. You simply right mouse click on it. Oh, let me get my mouse actually. And you can say compressed assignment 1. If you're on a Windows system, you can zip it together. Give me this file. It's the whole project. And inside of the project, if you look at it, we have those main and we have temp. You just want to give me main and temp, give me main and temp. I don't need the whole project. If you want to make your life easier, give me the whole project. And that one works just fine. I can't give you this project, you have to do it on your own. And what are you going to do with this project? You're going to go into Canvas. And into Canvas, you're going to click on the assignment link. I believe that people might be going into Canvas because this, oops, no, I'm into Google. No. It is quite possible that the internet's not running properly right now. No, it's running. No, we want to go Canvas. Canvas. Canvas is not working with Safari. Canvas. Canvas. Courses. Programming language concepts. I'm going to change this due date. This program number 2 is not due on the 26th. I will be changing it momentarily as soon as I get you guys out of here. But program number 1 is due on the 26th. So program number 1 is due on the 26th, which means you have an entire 2 weeks to finish up this program. If you so want to add those 2 features, you can. You don't have to. We'll do it in class next time. You want to turn it in before you come to class next time. That's assignment number 1, program number 1. I'm going to change this due date. It's going to be now on the 9th instead of the 26th, but I'll do that later. So don't stress on it. Only one program is due, and you've already done it. And the way that you submit it is you go over to assignments, and I believe you have a submission on the right-hand side. In the if you go into assignment number 1, I believe there's something on the right-hand side over here that says upload. You upload the zip file, or you could upload more than one file. You could take both of the 2.java files and stick them in there if you want as well. And if you're lost and you're still looking for the videos at the end when we wrap everything up, I'll be putting the rest of the videos here so you'll be able to look at this. And I'll clearly label this video number 5, and it will be labeled with assignment number 1 overview, so you'll see it. So at this point I'm going to stop this recording, stop capture.